All right, so up until today, we've been working with those polar equations, but we haven't really done anything with them. So it's like, hey, here's this equation, and now we're gonna like graph it and see what it actually is. So just like we can write rectangular points in polar coordinates, you can go back and forth. You do that with your equations as well, which we did yesterday. So now you're just gonna graph them. So yeah, that's what we're gonna do. Okay, so for looking at this first one, we've got pi, or not pi, that's a theta, equals pi over 3. So we kind of need to like convert that into something that you could actually graph. So it's easier for us to graph in rectangular coordinates because like we know what that is, right? So you could do tangent of each side, right? Because we know that tangent of theta is what? Over x, yeah. So if we do tangent of each side, we'll have tangent of theta equals tangent of pi over 3. And so tangent of theta is y over x. And what is tangent of pi over 3? Yeah? We want to graph this. We probably should have like y equals, right? Because most of the things that we know how to graph, they're like y equals. So what should we do to get y by itself? Multiply by x, so you're going to have y equals square root of 3 times x. So how would we graph that? Or when we graph that, what's it going to look like? We got y equals some number in front of x. So what if it was like y equals 2x or y equals 3x? Our slope is square root of 3. What's your y-intercept? 0. What is this going to make when you graph it? A line, yeah? So anytime you've got like theta equals something, it's just going to make a line. So we're going to put it at pi over 3, which is right here. So this is theta equals pi over 3, or we got it as y equals root 3 times x. Y'all can't see any of that. There it is. Questions on that one? All right, so the next one we're looking at is r equals 3. So we want to get that in like rectangular coordinates so that we could graph it. So what would you need to do? Square both sides. So then you'll have r squared equals 9. And what does r squared equal? X squared plus y squared equals 9. When we graph that, what's it going to be? Do we know your standard form for a circle? Obviously not. That's your standard form for a circle? Is that not this? Oh yeah. So your center's at 0, 0. What's your radius going to be? 3. Which we knew that to start with. Your radius is going to be 3. So you're just going to go out 3 and go 3 in every direction and make a circle. But you already have a circle drawn there, so hopefully yours won't be too ugly. That doesn't help me much. And that circle was still pretty gross. And so we'll say that this one is r 3, 4. Questions on that one? So those are like your basic ones. We're going to do some more of that at the next section. So for number 1 down here, we've got theta equals pi over 4. So just like we did theta equals pi over 3, we'll do tangent of each side. So tangent of theta equals tangent of pi over 4. So then we know y over x equals what? What's tangent of pi over 4? 1. So then y equals x, yeah? That okay? So then we can graph that line. It's going to go right here. And that's it. Questions there? Okay. So number 2, we've got r sine theta equals 2. What is r sine theta? So this is basically just y equals 2, right? What kind of line is that going to be? Horizontal. I don't know if y'all have ever heard of like Hoyvux.
Oh, yeah.
I use it with my Math 1 kids a lot. HOYVUX. So like if it's y equals, it's a horizontal line. If it's x equals, it's a vertical line. So if you get confused on those, it might be helpful for you to jot that down. So we're going to have a horizontal line at positive 2. So just go to positive 2, draw a horizontal line, and that's it. And then number 3 over there, we've got r cosine theta equals negative 3. So what is r cosine theta? X, that's basically just x equals negative 3. So is that going to be a horizontal line or a vertical line? Vertical, so we're going to go over to negative 3 and draw a vertical line. Mine's not very straight, but we try. And that's it. Is that okay? So this bottom section is basically just summarizing what we did up there. So if you've got theta equals some angle, it's going to be like a regular line. If you've got r sine of something, it's going to be a horizontal line. If you've got r cosine of something, it's going to be a vertical line. So that's kind of like your little cheat sheet for that there. Questions? Okay, cool. So we'll move on to the next part. So these are going to be circles. So we've got your polar equations, but we want to convert it into rectangular form because that's just easier for us to graph, I think. So how do we need to go about doing that for the first one? Multiply by r, so that's going to give you r squared equals 4r sine theta. And what is r squared? So x squared plus y squared equals 4 times, what is r sine theta? Y. So we're going to have to move that 4y over, and then to get it in standard form for a circle, you've got to complete the square. Is that something that we're familiar with at all? It's been a long time, right? So let's briefly review that. So you're going to have x squared plus y squared minus 4y, and then we're going to add in something equals 0. Yeah? So do y'all remember how to find that number that you add in to complete the square? B over 2 squared, so negative 4 over 2. Negative 4 divided by 2. Negative 2, square that, you get 4. So we'll add in a 4 here. You have to add it to the other side as well to balance out. So then when you factor that, you're going to have x squared, and then all this y stuff is going to factor to y minus 2 all squared equals 4. Questions on that? That should be a plus right there. So I'm assuming that we probably don't know. Can we tell what our radius is?
4, 2,
remember that standard form that we read earlier? This is r squared. So the square root of 4 is going to be your radius, so 2. Our radius is 2. Do you know where your center is? Do you know about that? It comes from whatever's going on with x and y. So anytime you're inside parentheses, remember we take the opposite sign. So it's going to be at 0, 2 for your center. This is all stuff that you should have covered in Math 3. I'm guessing we didn't get there. Okay, that's fine. We have a whole unit on circles and other conic sections. So we're going to put our center at 0, 2. So we'll go 0, 2. That's our center. Your radius is 2, so basically just count 2 units in every direction. So we'll go up 2, we'll go down 2, we'll go to the right 2, and to the left 2. And my circle's real ugly, so don't judge it. Questions? Usually looks more like a diamond. So oh, I'm saying mine usually ends up looking more like a diamond. So I guess this is an improvement for me. Questions? All right. So looking at number 2, we're going to do the exact same thing. How do we go about getting this into rectangular form? Multiply by r, that's going to give you r squared equals negative 2r cosine theta. So what is r squared? And what is r cosine? So again, you're going to have to complete the square. So we need to go through that together. I'm assuming yes. Okay, so you're going to do b divided by 2. So 2, negative 2 divided by 2, what do you get? 1 squared gives you 1. Yes, that should be positive 2. I keep forgetting to do that lately. Switch my signs. So then we got to add a 1 to the other side as well. So that's going to factor into x plus 1 all squared plus y squared equals 1. Hey, reading him. Hey. Sure. Bye, Ethan. No cookies for you. Sorry. So where's our center going to be for this one? Negative 1, 0. And what's our radius? 1. Are we okay with that? Have we like really never done circles?
It's to the left 1, up down, radius is 1.
That one wasn't too bad. The smaller they are, the better they are. When they get really big is when they get really bad. So those are your circles. Again, you've got like another cheat sheet here for like what your formulas are. That are going to get you certain circles wherever. Some people tell you to like memorize all those like polar equations, like what polar equation is going to give you what. But I think it's easier to just like convert it to rectangular and then graph it because you know how to graph circles. We don't know how to graph circles yet, or maybe we're learning to, but we'll get better at that later. So there's a couple other kinds of things that we can have. So we've done lines, and you can get circles. Those are easy. Then we have these new shapes that are called, I'm going to say this wrong, I know that I am, limacon? I don't know. Limacon. Whatever. You got one of those little things. So sometimes they got a loop inside, sometimes they don't. And then sometimes you have a cardioid. So the difference between these two is in your polar equation, these numbers are going to be the same for a cardioid. If these numbers are different, it's going to be a limacon with a dimple. That okay? So there's like your cheat sheet for that. Just kind of tells you how all that works, and we're gonna go do some. Right here, this little box is kind of important. So if your equation is in terms of cosine, it's gonna be symmetric about your polar axis, so your horizontal axis. And then if it's in terms of sine, it's gonna be symmetric about the pi over 2 axis. That's like your vertical axis. That's in terms of sine. Yeah. So you might wanna like highlight that or something. I'm sorry. Alrighty, so we're gonna go try some. So this is gonna be kind of cute. We've got r equals 2 minus 2 sine theta. So what is your a value? Hint, it's the first number. 2. So what would your b value be? It's actually just 2. Because those standard forms that we have include the plus or minus in there. So whatever the number is, you just take that number, like absolute value. Okay. So these numbers tell us that it's, because they're the same, since a equals b, it's going to be a cardioid. And what does that kind of sound like? Cardi B, yeah. Cardio, right? And so what does that mean? Heart. So what shape do you think this is going to take on? A heart. Isn't that going to be cute? So since it's in terms of sine, it's going to be symmetric along the pi over 2 axis, so your vertical axis. And then because it's minus, that just means that the point is going to be on the bottom, or like your dimple is going to be on the top. So it's on the negative side. And then to find the length of it, you're going to do 2 times a. So what was our a value? 2. So 2 times 2 is going to give us 4. So it's going to be centered at 0. And it's going to cross out at 2 on either side. And then the length is going to go all the way down to 4. 1, 2, 3, 4. And we got to make a kind of like a little dimple, a little heart shape up here. And that's how that's going to go. It's real ugly. It looks much cuter in my notes than I did it the first time. But yeah, so that's that. So then we're going to do some limestone. I guess that's how you say that. I've said it wrong my entire life. Some limestone graphs. So you've got your formulas up there for how those work. So again, if it's cosine, it's going to be along the polar axis. If it's sine, it's going to be symmetric around the vertical axis, your pi over 2 axis. If A is bigger than B, then there's not going to be an inner loop. You'll just have that little dimple, kind of like we did up here. But if A is smaller than B, then you are going to have that loop inside, and we're going to do one of each. So for number 2, we've got r equals 3 plus 2 cosine theta. So what is our A value? 3. And what is your B value? 2. So which is bigger, A or B? So since A is bigger than B, are we going to have an inner loop or no inner loop? No inner loop. And are we dealing with sine or cosine? Cosine, so since it's cosine, we're going to be symmetric about which axis? Polar axis. So we're not going to have an inner loop, we're going to have that dimple. So your dimple is going to happen at B minus A. So B was 2 and A was 3, so what is 2 minus 3? -1. So our dimple is going to happen at -1. And then the end of it is going to be at b plus a. And so again, we're going to have 2 plus 3 this time, which is what? 5. Okay, so let's get this graph. So our dimple is going to happen at -1. And then we're going all the way out to +5. So when you graph this, you just kind of have to come out a little bit and then loop back to 5. And come out a little bit and then loop back to 5. Top half that didn't look bad. Questions? Huh? So looking at number 3, this time, what is our A value? Your A is 1. What is your B? 2. So since A is less than B, what does that mean? You're going to have an inner loop. And again, you're in terms of cosine, so which axis are we going to be symmetric about? So we'll be along the polar axis. So our loop is still going to happen, like same place where our dimple happens, so we'll do B minus A again. And what is B? B was 2, so 2 minus 1 gives you 2 minus 1 is 1. Yeah? Then to see where it ends, that's where you'll do B plus A. So 2 plus 1, 3. So these are a little bit trickier. So you've got to make a little loop happen around the 1. So this is not going to be cute, but it's okay. Oh, that was real ugly, but that's all right. Pretend that came in like this instead of going down so far. And in a second, I'm going to show you how to do these on the calculator, so that you don't have to worry about doing it by hand. That's so ugly. Like mine. Questions on this? It's supposed to be on the It's supposed to kind of look more like this. I feel bad when I was in pins, I couldn't turn back. So it's just supposed to go around the origin a little bit. Yeah. So there's like, well, 2 more kinds that we're going to talk about. So the next one we're talking about is roses. And so these are the cutest, I think. So that's just when you have like sine of something or cosine of something. So the big thing on these is like how many petals they have. So if your number in front of theta is odd, that's how many petals you have. If that number in front of theta is even, then you're going to have twice that many petals. That's basically all you have to remember for these. And then the number in front, your A value, tells you how far out they go. So it's like your radius again. So we're going to do a couple of those. So you've got R equals 2 sine of 3 theta. So your A value is what? 2. And your N value, your number in front of theta is 3. So since it's odd, that means you're only going to have 3 petals. The A value tells that they're each going to go out to 2. Their radius is going to be 2. And so since it's sine, we're going to be like kind of in the middle of each quadrant, except for like the bottom one. So it's going to end up looking something like this. And so if y'all wanted to get like for real serious with these, you can make a table just like you do with any function for like x and y values. So you'll just pick different values for theta and plug in. And that'll give you all the points. And so it's really neat when you plot these. You actually like start up here and then you come down and then around and around and then you come back up and plot this way and then they come back down that way. So, I mean, it's interesting to see, but we're not going to do that unless y'all just really want to. But I feel like you don't care that much, so we won't. So looking at the next one, what's our A value for that one? 2. What is our N value this time? 2. So that means because it's even, how many petals are we going to have? 4. Yeah? So, and since it's cosine, everything's going to be like on the axis this time. So you're going to have 1 petal here, we'll have another petal here, 1 here, and our 4th one here. And so the more petals you have, they just kind of get like more compact in there, so they're skinnier. Yeah, that's it. Questions on those? All right, so the last section that we're going to talk about, I'm not even going to pretend that I know how to say this word, but they're just like figure 8 shapes. So here's your formulas that are going to give you those. The A is still your length, kind of like your radius again. And if it's sine, it's going to be on the diagonal. If it's cosine, it's going to be on the polar axis, and that's it. So we're looking at number 3. What is your A value? A squared is 9, so A would be 3. So that means you're going to have your little figure 8's going to go out to 3, and we'll have our little loop here, and go out to 3 here, and another little loop there. So mine's not real cute, but nothing I've done today has been real cute. And if you're looking at the next one over there, what's our A value this time for number 4? Your A value is 2, and it's cosine, so we're going to be on that polar axis, so you'll go out to 2 on each side. This one's going to be a little bit cuter. I'm going to try harder. That one looks much more like a figure 8. Generally, the shorter your A value, or like your petal is, the fatter it's going to be. And if it's out further, it's going to be skinnier. And then like the more of them that you have, like up here, if you have a ton of petals, if you have like 8, they're going to all be skinnier too. Does that make any sense? So kind of like the bigger your numbers get, the skinnier all this stuff gets. That'd be a good way to think about it. The last thing that you're talking about is spirals. We're not going to graph any of those by hand, but this is what they are. So can we start looking at these in your calculator now? Yeah, let's do that. Okay, so if you don't have your calculator, you need to get your calculator real quick. And clear everything out so that there's not anything funky happening already, and we're going to go to your graphs. And which one do we want to do first? Yeah, you need to be in radian mode, so if you're not, make sure that you switch to that real quick. I'm going to do that. Yeah. So, which one do we want to do first? We'll do the spiral first because I think these are really cool to see. So your equation that we're talking about for your spiral is right here. So if you want to graph any type of polar equation in your calculator, you've got to change how you enter those. So I don't know if y'all played a whole lot with that yet, but if you go to menu and then go to graph, entry, edit, there's a bunch of different templates that your calculator has built in that you can use here. We're going to go to polar. Shocker, right? Menu, graph, entry, edit, and choose polar. I know there's like a glare on there. Can y'all see okay? Oh, there's not even sun today. I don't know why that's happening. Is it the light? Oh. Now that we have lights that work. Okay, so we're going to type in this spiral one here. So we need an E, and then I believe that's supposed to be an exponent, so E to the theta over 5. And your theta's under the pi button. Yeah. So there's your little spiral. Is that okay? So what's really cool about your polar graphs is that you can keep going for like ever and ever, right? Just like the unit circle, like it stops at 2 pi and then it starts repeating. So we could go to 4 pi, and what do you think might happen? Do you think the graph's going to change? Going to keep going around. So what is 4 pi? $12.57. So when you hit tab to like edit the equation that you typed in, do you see at the bottom where it says 0 less than theta less than 6.28? So 6.28 is 2 pi, right? So if we want to go to 4 pi, let's change that to 12 point, what did we say it was? I can't remember. Well, it was not 12.8. It was like 12.57, I think. Gosh darn it. Okay. Okay, hang on. Why is it not doing that?
You gotta go up.
Oh my gosh, I'm an idiot. It's fine. There we go. So it keeps spiraling. It's going to keep getting bigger and bigger and bigger and bigger. So you could change it. Let's pick a number, any number, preferably an even number. 8, so let's say 8 pi. I'm just going to type in 8 pi. And our window is not big enough to see all that anymore, but if you zoom out, you'll see that's going to keep going. Is that okay? Isn't that kind of cool? I think it's neat. So, let's do another one. Yes. So, let's just clear everything out. So, Control N. And we're going to start from scratch. We're going to start all over again. We're going to do some more. So let's go to a brand new graph. You need to make sure that you are in radian mode, but if you just cleared everything out, you should be in radian mode. But you can check that on your document settings real quick. And just make sure that you're in radian mode. I am, so I'm going to leave it there. Not on mine. I don't know. It just doesn't ever do that on here. It's because it's the old version. I don't have the most updated software. But anyway, so we're going to go to menu and then to graph entry / edit. And we're choosing polar. So it should be like menu 3, 4. Is that not what y'all said? Is it different numbers for y'all? Yeah, okay. Well, like I just said, mine has older software on it than y'all's does, so it's different numbers, but it's still the same stuff. So menu, graph entry, edit, and choose polar. Are we all here? Yeah? Alright, so let's graph, what do you want to graph? Let's do this one, because that'll be easy. So we've got r equals, so we'll do 2 sine of 3 theta. And where's your theta at? On the pi button, we'll choose theta. So that's what we should look like. Yeah? That okay? Let's go back and do one that's a little bit more complicated, because like those llama signs or whatever, I think they're awful to graph. So let's do the one with the loop, because I could not draw that to save my life. So I'm just going to arrow up and delete out what we had. Change that to 1 plus 2 cosine of theta. So that shows you what your graph should look like there, which looks a lot better than the one that I drew. Is it starting to work for us? Yeah? We'll look at that in a second. Questions on anything? Do we need to do some more? Okay, cool. So that's all I got.